SpectraVis is a hyperspectral image visualization and analysis tool. This is the first window of SpectraVis where we provide the data inputs that will be used further for processing. The first selection is that of a hyperspectral image in a NumPy array format. So we'll go ahead and select a sample image. After that, we select the metadata. The metadata basically contains the details for which band corresponds to which wavelength, which will be used for processing the hyperspectral data cube. Next is an optional selection of the spectral library. The spectral library contains pre-stored data of known spectras, which we can use for comparison. Now we select the run analysis, which will open the main tool. We'll go ahead and see what all features are there. This is the main tool interface. There are 3 tabs in it: Visualization, Library Creation, and SAM Comparison. So firstly, we'll look at visualization. We can select the number of pixels we want to select at max. Let's say we want to select at max 10 pixels. We can set it at 10. Then we can go ahead and select multiple pixels, and we'll see their spectra being formed on the right hand side. This is a graph that gets generated dynamically. Now say you want to remove a selection. You can select undo to remove any of the graphs, or another feature is you can entirely reset the graph also. That will remove all the selections and give you a fresh start. The second tool is a spectral library creation. Now let's say this image is correct and validated. We can use this to create a spectral library of known spectras, which we can further use to compare between different pixels. Let's say I have this green region. As you see, the spectrum of that pixel is shown on the right. Now we will go ahead and select a region, and let's say this, and I say it to be demo. Now I can save this entry. This says this entry has been saved with label demo. Now we can go ahead and have a look at the library that has been made. So as you see, the demo spectra has been stored and is demonstrated in brown color. These are a few other spectras that has been stored beforehand by selecting random points from this image, and the following labels have been given for the demo. The third tool, coming to the third tool, is our comparison tool. The comparison uses a SAM score in radians to compare the similarity between two spectras. So a low score signifies a similar spectra, whereas a high score signifies distinct spectra. So let's say I select this black pixel here. Now you can see that it's predicting with high confidence that it's a black stored spectrum. So, and there are thresholds defined like high confidence threshold and low confidence threshold, and based on that certain classifications are made, like the best high confidence match, and all high confidence matched are labeled in green. Then there is a low confidence match and best low confidence, and no matches, which are like very different from what we have selecting. Now we can see for different pixels, like we see the classification, how it is being done. If it's very different, then we see that there is no match as per the library that we have. As the library grows, we can have multiple comparisons done. This is how SpectraVis works right now. It's a good start, and there are many features to come. But for foundational analysis, this serves to be a great tool made completely using Python, and it's open source.